A couple new rules to talk about. That's why I thought it would be a good time to pause and look at this here. Okay, we're doing what's called reflection in parallel lines. As you can see, I've already drawn, there's two parallel lines here. When we reflect it twice over these two parallel lines, like we always did, like we're going to call these the y-axes. Notice that between the two parallel lines is what we're looking at here as far as the distance. It's important to notice what that distance is. Because when we go from the original thing, reflect it once and reflect it again, it's going to give us a total distance of 2 times d. So that means we're going to take 2 times 3, which equals 6, and that gives the distance that. Now, the question I want to ask you is as you see from our original one all the way to the final one, what kind of a combination of the three things that we've talked about before, which was a reflection, a translation, which means a slide, or a rotation, does this resemble? Going from the original one to the final one. If I were to cut out one in the middle, what would it originally be, or the final answer be? Notice that they're exactly the same. They're just moved from one part to another. That means this is called a slide. So when we do a double reflection over parallel lines, we're just going to get ourselves a reflection. A slide or translation. Okay. Now, same concept when we're going down here to reflection in the intersecting lines. Okay. So here we go with this scenario. Here's our original one. Then we have x degrees. So this is the degrees of things we're talking about here. Okay. And then degrees. So let's say, for instance, let's go 25 degrees. Okay, is x. Again, same scenario up here. Because it's 2D, we're going to do the same thing with our degrees. When we do our rotation, it's going to be 2x for this whole thing. So therefore, I'm going the wrong way again. We're going counterclockwise this way. First image, then second image. Therefore, it's going to be so if I have x equal to 25, we're going to take 2 times 25, and that equals 50-degree rotation again. Reflections, again, imitate, again, those kind of things here. So, with that being said, move this up here. And we're looking at our last few examples here. So here's our first one. So what we want to do is we're going to reflect again across two parallel lines. So that means H will be reflected here. Okay, we'll call it H prime. We're doing our best we can here. We'll call this E prime. F is about the same here. We'll go F prime and then G prime. Again, same thing that we did up above. So we get a close, so we're matching what we do. Then we want to do the same thing again, where we got E matches with E, F matches with F, okay, that's E double prime, and F double prime, G matches with G, okay, and H matches with H. And then we get our wonderful little picture. It looks kind of like this. I know it's horrible, and I'm not being exact because I don't have a rule or anything like that too. Again, if I were to take this image and again reflect it across two parallel lines, what kind of an image, or what does it say, describe the single transformation that will maps from here to here? And we talked about that up here, and what did we say it was? It is a what? Slide or a translation. Okay. Now, a nice thing about this one over here is we already know the distance if we do a double reflection, so we don't have to really do that. We just have to do what? Describe it. Again, a double parallel line means that it's going to be a translation or a slide. If the distance is 2, excuse me. That means all we have to do is, as we did up here, all we have to do is just find what 2D is. So we just take 2 times it by 2, and we get an answer of 4. Okay? Now, interesting about this one, this is a little bit interesting because what we have here is we have the final thing here, and we need to go backwards. So what it says here is to describe the pre-image given the image and the composition of this. So we got to work backwards. So here's our final product, and we did a translation. So all we want to do is we want to move it backwards so it looks something like this. And I'm just going to kind of do a general picture of this. just like that. And then it says we need to do a what? Reflection. So that means it's going to reflect this way. So we're going to go, so since our stem kind of goes this way, the stem has to kind of go this way. So it goes opposite. And then we go 1, 2, 3, 4. Okay. So that's what they're talking about. So we're going to do the same thing over here. Okay. We're going to go backwards again. So it says we want a rotation of 880 degrees about the origin, then reflect it across x-axis. So we're going to go what? Backwards. So we're going to do that one first. So that means we're going to take the x-axis, draw a line through it. Now remember, reflection means it goes on the opposite side by the same amount of units that we've gotten. Okay, so C double prime is here. So that means we're going to go what? C prime here because we went 1 unit down. That means we go 1 unit up. Now B is 2 units up. That means we're going to go 2 units down. Okay, gives us there. And then A is 1 unit above. So that means A single prime is going to go below. Okay, so this would be our answer here. Now, it's important because the next part is we're talking about a rotation of 180 degrees. So with that being said, that means it's probably good that we write down our coordinates for each one of these. So let's start with A prime, which is at 1, 2, 3, 1. So we're going to go -3, -1. B prime is 1, comma, or -1, -2. And C prime is 1, 1. That makes it really nice and easy. Now remember, the rule for 180 degrees is x comma y gives us -x, -y. Okay? So let's go ahead and let's put in our new coordinates for this. So we're going to just call this original, so like we work backwards. So this is going to give me 3 and 1 because we changed it to their opposites. B is going to be 1, comma 2, and then C is going to be -1, comma -1. And then we're just going to go ahead and plot those points on there. So here we go. 3, 1, 1, 2, 3, up 1. That's our A original. Okay, this is 1, 2. B, and then C is going to be -1, -1, which would be down here. And that would be our C. And that would be our original one there. So let's go ahead and draw lines. Here, boy, that just makes a big old mess there, didn't it? But we get the general idea. So our final answer is what is in green. So that's what we get to do and work on today for 3.4. And hopefully that helped you out. Gives you some answers to some general ideas of what you can do and what you can't do. Remember, you can look at these for your announcements for everything you get to do for this class this week, and then look for these posted on the days that we're going to be talking about these for your for the week. Okay. All right. If you guys have any questions, just make sure you contact me, and we'll take care of everything else. All right. Have a good day.